Reactions of benzene. Now, benzene is one that students either love it or hate it. There is no in between. But for benzene, there is one thing that you should know that is very, 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 let's say it a couple of more times, very, very important. Okay? Because benzene is a functional group. I know that we give it so much weight, and even in the exams, it's not proportional to everything else. But benzene is the same functional group as an aldehyde, as a carboxylic acid, as an alcohol, as halogen alkane. So when you're dealing with benzene, you have reactions for the functionality, and then you can have a side group. So if I have a methyl benzene, the methyl will react as a normal alkane. If I have phenyl ethene, the ethene reacts as a normal alkene. But for benzene, you have a number of reactions that are similar. These are all electrophilic substitutions, and you have hydrogenation. So, sulfonation, it's concentrated H2SO4 and reflux. Sometimes you see this as dissolved SO3 is the same thing. You are adding SO3H. You are making a new sulfur carbon bond. This is a reversible reaction, so it can be used to actually act as a protecting group. Nitration, HNO3 and H2SO4 at 155 degrees Celsius. This is useful because it can both make an amine, so phenylamine, with the with both the phenylamine and the SO3H being in a decent position that we can actually make phenols. So phenol, we can't have an electrophile which is OH plus. Therefore, it has to be made through something else. Acylation and alkylation, addition of a carbon group. Acylation, you're adding a carbonyl. Alkylation, you are adding an alkyl group. Acylation requires an acid chloride. Alkylation requires a halogen alkane. Please note that all these three use the same conditions. AlCl3 as a catalyst, reflux, and you are also adding a chlorinated compound. Chlorine for chlorination, CH3Cl for alkylation, CH3COCl for acylation. Bromination, okay, is the same as chlorination, but instead of using AlCl3, you use the FeBr3 or AlBr3. Now, it will work. So, a lot of students ask me, but sir, will it actually work if I use AlCl3 for bromine? Yes. But by definition, and I love saying this because I want to explain it properly, but by definition, the catalyst should remain unchanged. So because I'm exchanging the chlorine back and forth with the catalyst, it might not remain as FeBr3 if I add chlorine to it, or AlCl3 if I add Br2. So by definition, it will not be a catalyst because it would be changed by the end. But it will work. I mean, we've used it in the lab. Because normally the catalyst you will simply throw away at the end. Okay? Now, hydrogenation is addition of hydrogen. Issa,
So, allora il-reagents tal-option
tal-H2, it's nickel, 300 degrees Celsius, 30 atmospheres. Normally 300 degrees Celsius should be enough, ta? From here to here. So this is to the diazonium salt.
Okay.
Okay? This, if I recall correctly, it's a NaOH. Even more, don't do it reflux. Do it, give it at a temperature. Or you can say fuse. Because even though it's refluxing pretty much, and it's refluxing because this has a very, very, very high melting point or boiling point, and this is a solid. Together, they are two solids, therefore it's called fusing, not reflux. Fusing is when you melt two solids together. Then there is one other reaction, and I want to discuss this. And then I will simply discuss a little bit the work you have today. So this is UV. Now, the tricky bit is to note that if I have methyl, by the way, it will be the methyl group which reacts first. Okay? Again, you need energy to break the localization. Even though there is enough energy to break it, the preferential treatment will be the CH3. Okay? Now, having said all of that, these are all the reactions of benzene. You can have some reactions for methyl benzene that we haven't covered. We can have some reactions for other compounds that we haven't covered. But start with benzene. Today's work is I don't want to speak about. Let's open any. I don't want to actually speak about the reaction. The questions. Those will be fine. I know you. Today's work. It's this. You have, for example, ethene to propanol, ethine to ethanol, ethane to propanoic acid. For these, I'm not trying to trick you. Okay, let's put it that way. I'm not trying to trick you, but because we're now skip the step, we're going to two to three. Sometimes it might not come directly to you. Okay, so if you don't manage to do them all, it's fine. I presume that I will have some time to actually send you the material, send you the answers around 3 for these. But if it's a little bit later, don't be surprised. Okay? Because I'm not sure. I know that I have selected with the intermediates, but I'm not entirely sure what the time I've given them was. Okay? But one thing at a time, and you should be fine.